This is a basic distillation setup. Here we have a flask with, well, in this case I'm just using water just to use as the example of what we could do. So we've got the Bunsen heating up the water. The water will be turning to steam. Now that evaporated water can come up here. We have a thermometer in the top. We could read the temperature of the steam, well, from the other side we can. Now that steam passes down through this middle part. This is the condenser part of the distillation setup. Now what we actually have here, might be a bit hard to see, but we have a glass tube running through inside another glass tube. And between the tubes we have water, because we have water coming from the cold tap into the bottom of the condenser. It's running around the outside of the inner tube and then coming out this other tube here into the sink. So that hot steam is passing down into the condenser, being surrounded now by cold water, and we can see it's condensing back to a liquid. And then of course gravity is a thing, so it falls down and runs out into our collection beaker. So what I'm collecting is distilled water. Okay, so to run through that super quick again, maybe on a bit of a different angle. So we heat our mixture. And like I said, I'm just using water, but this could be any kind of mixture where one part will boil off. So we heat what we want to boiling temperature. It turns to a gas. That gas passes down through the condenser and, funnily enough, condenses. Because it's surrounded by that cold water, it condenses back to liquid and out it comes. That is our distillate. The distilled liquid that we're collecting, in this case water. So that's our distilled water just dripping out. So distillation is great for separating a solute from a solvent when you want to actually retain the solvent. Okay, you boil it off, you can pass it through the condenser, cool it down, it will condense back to a liquid, and you can let it drip into your beaker. Voila, you've retained your solvent. But what if we had a mixture of liquids? Well, this is what we have in this case. This is crude oil. Crude oil is a mixture of various hydrocarbons, different hydrocarbon liquids. So what we can do is called fractional distillation. We'd heat it up to about 60 or 70 degrees, and that will boil off the petrol. So the thing about fractional distillation is that the different liquids will have a different boiling point. So you heat it up a little bit, boil off the fraction, the part of the mixture with the lowest boiling point, in this case the petrol, and collect it. And when it stops dripping out the bottom, you know you've collected it all, and now we can heat it up. Let's heat it up to about 180 or so degrees Celsius, and we'll now boil off the naphtha. And so the naphtha will pass through the condenser and condense back to the liquid, drip out the end, and we'll collect that in our, obviously we would have to change the collection container, but in our second beaker we've now collected the naphtha. When that stops dripping out, we know all the naphtha has been collected. So we can change the collection beaker again, heat it up to about 220 degrees, and we will now start collecting the paraffin. So in this way, we change the temperature that we're heating the mixture, and one by one, the different parts of that mixture, so the different fractions of that mixture, will boil off and can be collected. Once we've collected our paraffin, it stopped dripping out. Let's heat it a bit more. Let's collect our kerosene. Same deal here. When it stops collecting, we'll heat it up even more, collect the diesel, then we'll collect the fuel oil, then we'll collect the lubricating oil. Now, because we're collecting different fractions of the original mixture, this is called fractional distillation.
Hey you, hit the like button. Yeah, and the subscribe one too. Yay!